In this video 4.7 we are going to be working with sequences and functions. By the end of the video and work time in class you should be able to say I can identify sequences and functions. A sequence is an ordered list of numbers that often form a pattern, and we will be looking at specific terms to figure out a pattern, and a term of a sequence is each number in that list. An arithmetic sequence is a specific type of sequence where the difference between the terms is constant. The difference is called the common difference. We've been looking at common differences when we've been looking at functions and writing their rules. So in this first sequence here, we have 5 to 8, 8 to 11, 11 to 14. And as we go up, we see that we're constantly adding 3. So that means that this is an arithmetic sequence where we would go then 17 and then 20 and so on. When you're going from 6 to 9, 9 to 13, and 13 to 17, we see, well, we'll go up by 3, and then here we're going up by 4, and then here we're going up by 4 again. We see that that is not constant. So that is not an arithmetic sequence. Some more examples here. Describe the pattern in each sequence and what are the next two terms of each sequence. So 4, 6, 8, 10, we see that we're adding 2 every time. So to describe that, you would say add 2 to the previous term. Or you could say number, but we call these terms. Each number is a term. And so that means if we're adding 2 constantly here, we would be at 12 and then at 14 for the next 2 terms. And we know that goes on forever. 1, 3, 9, and then 27. We see here the pattern is not arithmetic, but we're multiplying by 3. So multiply the previous term by 3. And so if we continue that, 27 times 3 gives you 81. And 81 times 3 gives you 243. So that would be the next 2 terms in that sequence. Tell whether the sequence is arithmetic. If it is, what is that common difference? So from 7 to 11 to 16 and 22, we see here we're going up by 4, and we're going up by 5, we're going up by 6. We see a pattern there, but it is not arithmetic because it's not constant, a constant change. So it's not arithmetic. Whereas in the next example here, from 3 to 9, we see we're adding 6. And this is constant, so we know it's arithmetic. And that common difference is 6. This is a rule that we use when we're coming up with an arithmetic sequence. A of n, this right here is the nth term of a sequence, which could be any number. So if I wanted to know the 100th term in a sequence, I would replace the n with the 100. If I wanted to know the 142nd term of a sequence, I would replace the n with 142. The a of 1, that is going to be the first term in a sequence. And once again, we have n. That's the term number you're looking at. So once again, if I replaced the previous a to the n with 100, that's where I'd put 100. If I replace that n with 142, I'd replace this n here with 142. And then we subtract 1 to that. And then the d that we multiply that by, because you can see the parentheses there, this right here is that common difference that we look for in our arithmetic sequences. So I'm going to show you how this works in a problem. Justine's grandfather puts $100 in his savings account for her on her first birthday. He puts 125, 150, 175 into the account on her next 3 birthdays. So what we can see here is if he starts 100 and then he goes up 125 the next year, 150 the next year, 175 the next year, we see that he's constantly adding an additional 25. So that constant difference here is 25. If this pattern continues, how much will Justine's grandfather put in the savings account on her 12th birthday? So that's the term we want to know. We want to know A of 12. So instead of A of n, we put A of 12. We're looking for the 12th term. And that equals, we're going back to that previous slide, A of 1, which is the first term. The first term here would be 100, because that's what he started with. That's the beginning, the first. And then if you go back to that previous slide, we add, and then in parentheses, it was n minus 1. Well, n here is 12 because we're looking for the 12th birthday. So 12 minus 1, and then times d, which is the common difference. And that would be 25 because that's what it's constantly going up by. So if I simplify this, A of 12, I have 100 plus 11 times 25. And when you do 11 times 25 plus 100, you get a total of $375. Can you say, I can identify sequences and functions? Write a summary and a reflection and be prepared with any questions for the work done in class.